Welcome back to the channel. Hope you're doing well today and you're giving it your all in 2026 to prepare for your Civil FE exam. Today we're actually redoing a problem that I did in the past, but I did mess up on, specifically when applying that productivity rate. So I want to make sure to redo this, show you the right steps, and get it right. This is easy points that we want to grab on exam day. And if you're looking for a Civil FE prep course, check out the link below. This course will prepare you in a very comprehensive way, even if you're out of school for a very long time, even if you work full-time, you have a family, you have a busy work schedule, it's going to be on demand, self-paced, and it will teach you everything, the knowledge and the skills you need to develop to confidently pass your Civil FE exam. The link is in the description below. Your challenge: pause the video and solve this first. You're finding the total labor cost. Pause the video, try to solve this first, then check your solution with mine. Okay, let's see if you did this right. What did you get? So let's quickly read this first, then write the givens. So quick skim over this. Concrete is to be placed for a 2,000 foot squared, so square foot parking lot slab with a thickness of 8 inches. Assume 5% waste overbuild on the volume. The placement and finish rate is 2.5 cubic yards per labor hour. Each finisher's base wage is $20 per hour, and the contractor uses 35% labor burden. That's for taxes, insurance, and small tools. The total labor cost for the work is most nearly what? What is the total labor cost? So that's what I need to find. Let's put that on the side. Find the total labor cost. So I'll call it labor cost for that one in dollars. So we are given the following, and I'm gonna go back to the problem and actually visualize this a little bit. That helps me a lot relating a paragraph to pictures. It doesn't have to be pretty. It just helps my brain retain what I'm given. That crucial part of what we're given must be clear. So 2,000 square foot parking lot with a thickness. Okay, that is a volume parking lot. So we can just draw that. Something basic. It doesn't have to be perfect. So let's say like this. It is a slab, and that has a thickness of 8 inches. Then we know the area, square foot. This is the area term, A for area. It's always going to be that top area of this is 2,000 foot squared. Okay. I'm done with this, accounting for that 5% waste. So that 5% waste, it tells us on the volume. It doesn't necessarily have to say on the volume. Even if it said just account for a waste of 5%, it's always on the material, on the concrete, on the asphalt, on the material itself. So we're going to say that we're going to waste 5% of this to account for that. So that is something we need to consider. So let's check that off. The placement finish rate is 2.5 yard to the third cubic yards per labor hour. So that's a productivity rate. So let's write that productivity rate. And that is going to be given as the 2.5 cubic yards. Now divide per part labor hour. Labor hour is given. Now, each finisher's base wage, so we're given the wage that we give for each finisher, which is technically the labor. The labor is $20 per hour. So the wage is that one. So that will be the $20 per labor. And that would be per that hour, which is effectively the labor hour. It's $20. The labor is the labor hour. So that's a tricky part that we must always account for. It's a finisher, so it's effectively one finisher, which is the laborer, the labor, $20 per that labor hour. That's given. And the contractor uses a 35% labor burden. So it's similar to the waste factor, but then they're going to say it's 35%. That would apply to which one? The productivity or the wage? That 35% will apply to the wage, 35%, and we'll see how we can adjust that at the end. Now again, the total labor cost is what we need to find. Let's dive into the solution. Question: what would you do first in the solution? So with these problems, typically if you're looking at estimating, construction estimating, if you're given something we're building, find that volume first. Sometimes it's per area. sometimes just the wall area, or we're building a wall which does have a volume. In this case, it's a slab. Let's find the total volume that we need, because that volume is dependent on that critical productivity rate, because it does have a volume of cubic yards per hour. So let's find the total volume in cubic yards first that we need to build this parking lot slab. So that's the first step. We're going to see that the volume, and I'll call it V with a dash here, volume, is always the area times the thickness, area times thickness, and then we can plug numbers in. So V stands for volume. The area in this case is 2,000 foot squared. Thickness is 8 inches. I want to make sure this 8 inches is in feet to keep the units consistent. So I'll account for that in the formula as I write it. So it will be the 2,000 foot squared times the thickness, which is 8 inches, and I know there's 12 inches in 1 foot. So I took care of that conversion there. The inches cancel, the foot goes to the top. So then we can find the volume, and that will be the volume for this in cubic feet. Foot squared times feet is cubic feet. So we get about 1333.33 cubic feet. Now that's a volume in cubic feet. Be careful that productivity rate is cubic yards. Units have to always match. So I'm going to do this again and say cubic feet to cubic yards, you just divide by 27. There's 27 cubic feet in 1 cubic yard. Just do that quickly in the calculator. You will get the answer in cubic yards as 49.383, and that will be in cubic yards. Excellent. Next step, is this the volume? Hope you're saying no. We need the waste. So the waste is 5%. That waste is 5%. This is gonna be 5% on top of this. 5% of this value will be a number, then you add it on this original value. That's what that's saying. But there's a different way to do this. I like doing it this way. It's just faster. So 5% means we multiply by a factor. It's called a waste factor. We often use this in surveying and the earthwork, as we learned in the course. So that 5% is going to be 1.05 factor. Here's other examples. 10% will be 1.10. 25% will be how much? 1.25. Multiply simply by that. Now 35% is how much? 1.35. Notice the pattern. That's the factor. So all I do here to get the real effective volume, I'll call it the volume effective. V effective will be the value that we have from up top, the V times the factor for 5%, which is 1.05. So if you plug that in, it will go up, and that will be by 5%. So it will be 51.852 cubic yards. That's the real one, the real effective volume, considering the waste. So we must account for that. Now, proceeding on to the next step. The next step, I'm just going to do one simple step, dimensional analysis, cancel units, and get the labor cost, the unknown. My unknown is a cost in dollar amount. So what I'm going to do is say labor cost will equal. So I'll start with the effective volume. Typically, that's what you will start with a similar problem like this. So that will be the 51.852 cubic yards. Then I'm going to cancel units. So we have the stuff on the bottom, stuff on top. To cancel the cubic yards, I know I need diagonal cubic yards. Where's that used? The productivity. So it's 2.5 per labor hour. So I'm going to flip it. It's going to be 2.5 cubic yards per 1 labor hour. So that part is done, and these cancel. Now let's continue. Labor hour. How can I cancel that? So I'm going to do again unit cancellation. Here I need somehow labor hour, and that is used where the wage, $20 per hour, and it's $20 technically per that labor hour. So I'm going to do is say it's $20 on top per 1 labor hour. Now these cancel. So at this point, we have $20. Are we done? We didn't account for one last one. This is done. All of this is used. We already used everything. Do that check. Okay, mistake here. I didn't use the 35, right? That's the last part. 35 is going to increase the wage for that labor burden. So that is going to be 35, and it is this factor, 1.35. It does apply to the wage itself. So it will be simply this times 1.35. That's all we have to do. We're increasing that by 1.35. Then doing this, we will get the labor cost. And let's see what we get for this. When you plug this all in the calculator, you're going to get almost exactly 560 for that labor cost. And notice how it's not dependent. It is not dependent on the number of finishers. This is the labor cost the contractor will pay either way. That total amount per that labor hour. So it is going to be 560. Most nearly it would be C. And these would have tripped you up if you, let's say, neglected the waste. Likely you'll get an answer choice. Or maybe you neglected the final labor burden. Very likely you'll have an answer choice here. So for problems like this, make sure you try to use everything. Sometimes there are distractors that you don't use, but that's rare for the FE exam. If it is, just know, stick to the logic, canceling units and applying them correctly, and make sure to keep the units consistent. Keep it up, and let's move on and keep practicing.